of civil engineering and primarily bridge engineering, I would say, from last 9 years. Uh, I have worked all around the world, working on different, conditions, different countries, different kind of structures that we have in the system in our India and the Europe and the Middle East. So we are going to discuss, those things one by one. As you all can see, as the topic of discussion in today's evening topic is RCC Bridge Design Engineering. So I'll cover that. Let me share my screen for that. Sandeep, is my screen visible now?
Yes, sir.
Okay. So first of all, if I mean generally talk about a bridge engineering, what we have in mind when we think of a bridge. Generally, most of the students or most of the people who are with us today in this meeting, they might know the a layman's term if I say they are from the civil background, but they know obviously much more than a layman that what a bridge is. It's not only the passage for them. They know that a lot of things we need to study before putting up the bridge at the place where it is, and what different kind of things are there in the bridges. So just to introduce those things, the basics of bridge engineering, that what different components we have in the bridge, how we decide that okay, this is the location where we have to put on the bridge, and then other many topics that why this bridge, why a slab RCC, why a T beam, why a pre-stressed beam, and if we talk about different arches, steel beams, different kind of special structures in India as well, they are now also coming up. So the basic idea of meeting up that students who are coming fresh from the curriculums, or maybe people who are working in the industry but haven't got that sort of exposure to what actually is happening in the industry. So to bridge the gap in between these two things, that okay, you have the knowledge, you know how to design the RCC, but do you know how to put on those things in a bridge? What are the different conditions under which we design a bridge? And what different kind of loadings we have to put on the bridge. So it is not something like only a one subject that we have to cover in a bridge engineering. So basically, why you choose this field? Because from my personal experience, if I say that if you design something in the office, and when it gets constructed on the site and public or people are actually using it, so you feel a moment of pride in yourself that you are able to give something to the nation and to the people of the country, that you have designed something. No doubt you are getting paid for it, but there is a sense of pride in that okay, whatever I am doing it, people will gonna use it. So it may happen in that whatever you are designing, it might be in some other country, or it might some other people who you don't know, they use it. But somewhere, some part of the world, people will be going over that bridge, and that gives you a sense of pride. And then again, you have that confidence that okay, you can do construction as well, you can do those parts very nicely if you understand those concepts, that how to make those things. If we say the opportunities in the couple of years, from last 3 to 4 years, I can say that like other in the past, what happens that the companies like MNCs of computer engineering, of electronics, they were coming up into the field, and people from USA, Canada, UK, and all these countries, they used to sublet the work to India. Now from last 4 years, this has started in civil engineering as well. Now people from Australia, from Europe, from Scandinavian countries, from Middle East, from Canada, and now from US as well. So they have started using India as their sublet market. They are doing it as at cheaper rates in India. So there is a huge market opening up with lot of companies coming up, not only smaller companies but also some larger companies as well. But to get through those, you always need a proper skill set to go through. This is fine that you know a lot of basic things from civil engineering. Can learn through these courses, these discussions with the experts, so that you can have an extra edge over those students if you are attending those interviews. And also you get to know what current things are being used in the market, what tools are being used in the market, and how they are being used. So the basic fundamentals, if we say that if civil engineering is only about structures, because I have been talking about bridges since the start, but what do you think that if we make a bridge, are we only using the structural engineering? So the answer would be a no. I'll make you understand in a very easy way. Let's see, we are watching a movie, and what we see a hero on the screen, and what we think that only hero is responsible for. He's singing, he's dancing, he's fighting, he is doing everything. But that is the case with the bridge as well. We see the bridge, that is the hero of our movie, but behind that there is so much of a study. I'll tell you the subjects that we will generally cover before making a bridge. The first and the foremost point is the survey that we conduct at the sites where we have to bring up the bridge. So all the survey you have to do. Then we have to do the soil engineering test, the geotechnical things. So all the soil engineering will apply. Then we have to do the hydrological calculations. So all your hydrology, basically you have to calculate how much water will be passing through that bridge. So you hydrology will also be included in that case. And then you have to design your highway as well. Otherwise you cannot fix the geometry. So your highway engineering also comes into the play. And then comes your materials, building materials, that if you want to use concrete, steel, or what kind of material you're using. So basically that also comes up into it. And then comes your quality control. And at the end, once you have all these things up, then comes the structural engineering. So then you basically do the structural engineering, you do all analysis, then you basically design your RCC and all these things, and then do the detailing part. So basically this is your drafting now, in which you do the detailing of RCC. And then once your bridge is completed, then you do its bill of quantities, basically the quantity work. And then you do the project management as well. So basically you cover a lot of courses in it. Mostly 10 to 11 courses of your curriculum you have to cover to reach upon a final stage on the bridge. One thing I missed is the traffic engineering. We have to calculate the traffic as well to find out that okay, we have to make a 2-lane bridge or a 4-lane or a 6-lane bridge. So that studies the OD surveys and the traffic surveys, the 7-day video surveys. We also have to conduct those sort of surveys. So you can say, I mean, we see only the structure as an hero, but there is a lot. There is a lot on the backside of that bridge. At least 3 to 4 years are there, and the studies and the preliminary studies that we conduct on the site, on the paper, on the laboratories, and then on the softwares as well. So there comes up in the mind of people that what softwares should we learn? So the first thing is that people are going into the 3D market now. They are learning all the FEM, all the plate analysis, all these things. But before moving on to that, before going to the the Revit and Lusas and Sophistic, all these kind of bigger softwares, you need to learn the basics first. If you know the basics, those softwares are just for your understanding. You will be the one guiding the software. Never let software guides you. So there is a demand for the softwares, but my concern as a my suggestion, or I can say, should is always that you should know the basics first. Then bridge. If you can see this bridge, this bridge lies in the state of Punjab. It's near Amritsar, over the river Satluj. I designed this bridge in the year 2015. It's a PSC bridge, pre-tensioned bridge, and have a span of around 32.57 meters and a 25-meter deck width. it rests on well foundations because we have a big river and there is a lot of water going on. So we have a well foundation in this one. So the component wise, if we talk that what constitutes a bridge. So basically we have a superstructures, substructure, and foundations. So these are the three main categories in which we divide our bridge. So I'll define them one by one to you just to have a fair look. You can see the superstructure. So everything that you see on the top above this yellow line, which is nothing but the bearing, this is known as superstructure. And everything which is below the yellow line is known as substructure till the ground. And below the ground, we have the foundations. So basically, we have these three components: superstructure, substructure, and then the foundations. Now, the superstructures, we can have a different sort of superstructures. Like I told that we can have different kind of spans that we generally fix with the other lot of calculations, a lot of site recommendations, and then hydrological calculations, and then geotechnical calculations as well that we conduct on the site. We basically, fix those spans with some studies. So then we can decide that where we can put a solid slab, a RCC T-beam, a PSC T-beam, or a steel composite. More or less, steel composites you can see and the railway bridges. If you happen to see railway bridges in your vicinity or anywhere, if you have traveled, you can see those big girders of steel. They are mostly painted with gray colors. So you can see those steel composite girders as well, systems that we generally use in the railway bridges. Then there are various factors through which we decide how we will go with any of these four options. Many checks that we do as per design, as per their deflection checks, as per their span length as well, and as per the width of the bridge as well, and also as per the loadings which are gonna come over that. There are different set of loadings as per Indian Road Congress codes. There are different set of loadings combinations, and then we have to see if our bridge is able to survive those forces or not. So this should be our main focus on that, how we decide those superstructure types. Then of course we have substructures, which is nothing but the pillars which is below the superstructure. Like I have shown you, there are no types in that, but in foundations we have shallow foundations. I hope if you are from a civil background, you already know this, but just to give you a rough brief idea, a shallow foundation like isolated footings or open foundations like we say, and then deep foundations. In deep foundations, we generally hear the name of pile foundation, but we do have one more which is well foundation. Like in this picture, you can see in this bridge we have used the well foundation, which is quite prominent in bridges. It's not prominent in the buildings, but it is quite prominent in the in the bridges, the well foundation. Then how do we decide these? There are various factors, I can say, various site studies, various river studies, that what kind of river we have, what kind of geotechnical recommendations we have, what kind of soil we have, and if there is any earthquake components are also there that we have to check for, if we can go with the liquefaction or not, that we also have to check. So there are numerous points that we need to figure out to finally come up with the thing which is safe in design and economic as well. We should not just be like that, okay, the design should be safe, but it should be economic as well to get the repeat orders and to survive in the market. Because generally in the college we just design for the safety of the system, but in the real world we have to be we have to economize as well various things to reach out as a optimum condition. Then type of superstructure, you may have seen these things. This is a typical solid slab that we have. This is a pier and a pier cap. These are the T-beams. The basic difference between RCC and PSC, that in PSC we will have these pre-stressed cables, and in RCC we will only have the steel, reinforced steel. In this, we will include some different, uh, techniques through which we can survive a T-beam till I can say 40 meters as well in PSC. And in RCC, we generally go with a bit lower spans. So this is how they look. I think this is the most common structure you can see anywhere. These are basically T-beams, and they are readily, used in almost everywhere in India. Foundations. This you can see. This is an open or a shallow foundation, as we can say. This is the pile
Hello.
foundation. Hello.
Hello. Sir, I can't able to.
Sir, yeah, you can continue, please.
Is there any issue?
No, it's okay. So you can continue, please.
Yeah, someone muted me actually. Okay, thank you. Yeah, so we have these open foundations or shallow foundations, which we can see. That's how foundation looks. It's open foundation. It rests on very near to the ground level. You can see. Then we have the deep foundations, which is this one is pile foundation. Then there are numerous factors that how we decide these pile foundations, where how many piles we need to put in, until what length we need to put in. And this is one typical example of well foundation. You can see that we generally make a well kind of a structure, as its name suggests, and then we reinforced all its walls, and then basically put the cap on the top of it. So this is the deepest foundation that we use. Pile we generally use till 20 to 25 meters, I can say. If we have to go 30, 35 meters, then we have these well foundation. These are the safest option that we have. It's a cumbersome task to make them, but if you are not left with any option, then we go with the well foundations. Mostly in Ganga River, you will see not any other foundation but the well foundations. A few small questions about these open shallow foundations, like I already have defined. Open is easy to construct, stable and cheap. You don't need extensive studies to do. In pile and well, we have to do extensive geotechnical studies. They are expensive, but they are viable for poor soil locations, both of them. But in well foundations, we generally put them where we have bigger rivers that can, cover the data. Then the stability wise, I would say the well foundation is more stable than the piles, but then again, it needs around 4 to 6 months to get constructed. So people, they tend to not to use well foundation as far as possible. We have to fix the sizes as per the loadings, various checks before heading towards, be it stability checks, be it different IRC and IS codes that we have to use. There are various IRC codes. IRC 78 is there for the foundations. Then soil investigations. We have to take up the boreholes and all these things, and then various other references we have to check if our whatever we have designed if is safe or not. And the most important thing is that whatever we have done on the paper, having all our calculations, all our things, the important part is to show those things onto the drawing so that people on the construction site can read the drawing and make it on the site. Because what happens in our industry, that the designer is different and the site persons are different. So your drawing, everything you make on a drawing, it should be crystal clear to everyone. Even if a layman is reading that drawing, they should be able to understand those detailing parts. So that is one most important thing. And then designing based on limit state methods. That's the only thing that we use in the market currently. Earlier we used to do on the working stress as well, but those things are not being in the use now. So that's right. Few failures, base pressure failures, sliding failures, overturning failures. These are the stability failures that can happen if the soil is poor. Scouring is basically the washing away of the soil due to the water. Then what studies we need to do to protect those things are also a part of bridge engineering. Then design mistakes and the supervision that I told you that whatever you have done is maybe fine, maybe correct on the paper, but and the person who is supervising that, who is doing the work on the site, should know what things are being put into the use. Then few iconic structures you can see if you tend to see those things, foundations and their evaluations and their evolutions, whatever we have in the system in the previous past. So in the Taj Mahal, they have used timber piles, and at few places they have used well foundation as well, because it is constructed near the bank of Yamuna. So the soil strata is not very good because it's on the banks of river. So it's not very good strata to hold on such a big structure. So they have made some timber piles which goes till deep till 10 meters as well, and that's how they have constructed this. So it is not that these technologies are not like very new to us. They have been people have been using them from several years now. But nowadays, the system of construction has eased out. You don't have to go with the timber piles. You can have RCC piles. You can have composite piles, and many other things are there in the system now, which makes our construction quite quick and safe as well. Similarly, you can see in the Eiffel Tower as well how they are, making up the foundations, and in the Tower of Pisa as well, you can see how they have made the foundations as well, which is more or less looks like a shallow foundation in that case. So these are the different foundations they have used in the iconic structures. Now, talking about scenario in jobs, like I told you that India now, they are targeting almost 30 kilometers per day in 1819. The country's target is to build at least 40 kilometers highway per day. So you can imagine how much workload is there in the industry. So people with the right mindset and with the right skills, they can get through a good job through this. Then India has also started up city mission, which included around say 100 cities, and then again they have to be completed by 2023. Then there are various hydroelectric projects and industrial projects coming up in India. And then the most important thing that I told you in the initial part of our discussion, that there are a lot of companies coming up which are subletting the work to India now. I can name few companies: Rambol, WSP, Acom, Jacobs is also there. Then we have Sistra as well. Mott McDonald is also there. So they have a good base in India already, but now they are expanding, their team as well, as per the requirements from the international market. So this is it from my side. If you have any Q&As or any point of discussions, I think Sandeep, you can have a word on that. You can describe them. If you can take over the mic.
Sure, sure. Thank you. It's really glad to have you, sir. We're really glad to have all of you also. So, do you guys have any query or any question? You can write in the chat so that you can have a talk on this. If you guys have any query, you can write in the chat so that we can see. I hope all of you have joined our WhatsApp group also. We have created one group, and we are willing to discuss about the different aspects of structural engineering, bridge design engineering, and different aspects of civil engineering. You can join there. It will be a two session. All of you can discuss by yourself, and I will be there. Sir is there. There's some nowadays for. See, sir has already explained this, right? There are so many softwares. There are some big heads like Midas, Sophistic, CSI Bridge. But what the thing is, before going to the you need to know the basics, the concepts. To know the concept, you have to use the basic part. Suppose the basic softwares like StatPro and other softwares are used for basic analysis and business. And another thing is, if you do not have the basic, then those softwares are just a tool, right? What is the range of salary? This depends on your skill. This depends on your skill, your experience. Now, if you do not have skill, cannot have experience, and if you cannot have experience, then you can understand what your salary is going to be. That should not be a matter of discussion, right? If you are thinking about the salary now, then you should have that skill. If you have, you can ask for salary. That depends in this engineering. I think.
I think I can
Yes,
answer this question. Yeah, Jishan, even Rakesh, your question is, everyone has that in mind. But like Sandeep said, if you have a right skill set, then only the sky is limit if you have a good experience once. But to start with, civil engineers do get a decent salary if the companies are good. Then future trends in the bridge engineering, I can say there are various things coming up. Earlier, we only used to make 4 lanes of bridges. But nowadays, even 8 lanes or 10 lanes are coming up. So most of the, things which will be created in India now, they all will be expressways. So we won't see more of 2 lanes or 4 lanes now. They will be the 6 lanes. And then again, the precast technology will be highly used coming up in the near future. Know about the brief description of your approach on a bridge design. See, yes. Yes,
Hello.
hi, Rakesh.
Sir? No, Rahul was here, sir.
Yes, Rahul. Can you
Hello.
please write your question?
Yeah, sir. My screen is not responding somehow, so that's why I unmuted my myself when asking for voice.
Yeah, just let me answer these questions. I'll come back to you. Okay.
Yeah, sure, sir.
Just give me 2 minutes. Yes, Rakesh, I'm in a bridge engineer in Canada. Will obviously get much more salary than in India. You cannot compare apples with oranges. Canadian people, they do pay a very nice salary, be it a WSP company is there or be it Jacobs is there. I have worked with both of them, so you cannot compare those salaries with Indians. Uh, Let us know brief description of your approach on bridge design. Yes, like I have told you that we have to do, keep in check various things in mind before going into a bridge design, not only the structure part, but also the other things. But my idea of designing a bridge is always to be on the safer side, to have a design which can be used even after 70, 80 years, because we design it for 100 years. And also to make them survive as many years as possible, because it's quite difficult to make a bridge and also costly thing. Which software is best for Midas or Bentley bridges? I would say if you are comparing Midas and Bentley bridges, Midas would be better because it is available in the market as well. But then again, when you're doing it for a company or somewhere, then you also have to see the cost part, because Midas is quite expensive. You have to spend around 12 lakhs for the software only to buy that software. Because if you are working in a company or somewhere, you cannot use that cracked softwares and all these things, because they have very limited things in them. So otherwise I would go with the Midas if you ask me. Yes, Rahul, can you please ask your question? Yes, CSC bridges, yes, it's a wonderful tool. Yes, to start any project on bridges you can, but yeah, always make
Sir, you
sure
told
that
about basic foundation. So, is there some specific kind of soil when we go there?
can you please be a bit louder? Rahul, sorry, I cannot hear you. Can you please be a bit louder? Okay. Uh, Yeah, Digvijay, I think CSI is a good tool to use, but you will be using it for analysis part, I suppose. Then for the design part, you have to, you may need to use some limit state methods for that. So be wary of those things as well. Otherwise, it's a wonderful tool to use.
Never mind, sir. My audio is still hanging, so it's
Rahul, we are not getting your voice actually. It's not clear. Can you please write in the chat?
For learning which software we have to use, for learning which software I'm not clear, Bala Morgan. For learning which software we have to use, we have StatPro. Yeah, you can learn through StatPro. I mean, StatPro is a basic tool, and it gives you almost everything if you are learning something. If you are on the initial stages of learning, I
sir,
think
my mobile screen has frozen somehow on this particular app, and otherwise it's working well fine. In this particular app,
yeah, you are audible now,
Yeah.
Rahul. Please ask your question. Please ask your question, Rahul.
Sir, two questions. I have two questions. First,
Yes.
I have two questions. First, about well foundation. So, is there some scrap of soil, because it's not possible to construct well foundation in the ground which we found generally in Chhattisgarh? I have worked in Narayanpur district. Bhanu Pratappur district. So there is no way you can construct that well foundation there. So, is there a specific kind of soil where you recommend
because
those well foundation?
because what happens, Rahul, when we have to sink that well foundation. It's not like that we will be excavating till 30 meters. So what we do is we have a cutting edge in a well foundation, and then we start sinking of the well foundation with the cantilage method, or maybe by putting on the weight on the top of it, right? So if you encounter some rocky strata or some boulders within the part of a well foundation, then it is not possible to sink that well foundation. So we have to have some soft soil to sink that well foundation. If you have boulders or rocky strata, then the cutting edge will get dismantled. So if you have a rock, then you don't have to go with the well foundation. You can simply go with a short pile or maybe open foundations. Then why do you need the well foundation? Well foundation we only provide where we have a soft soil. Yes, please ask.
So, sir, I got that. So my consultancy, there is a Naxalite influenced area.
Raipur,
so
right?
Go and go for. Can I ask in Hindi? I'm not very comfortable in Hindi.
हाँ, हिंदी में पूछ लीजिए आप, कोई बात नहीं. रायपुर में कहाँ पे?
रायपुर.
हिंदी में पूछ लीजिए आप, कोई बात नहीं.
रायपुर में नहीं सर, यहाँ रायपुर से कुछ दूर है. जी. रायपुर से कुछ दूर है, एक भानु प्रताप की जगह, नक्सल प्रभाव है. वहाँ पे है कि तो परमिशन नहीं मिल पाती, और परमिशन नहीं मिलती तो वहाँ पे ये होता है कि हम वहाँ पे वो कर रहे थे, बोरलॉक कर रहे थे, तो हम एनवे नहीं लेते. तो जब हमने सॉइल सैंपल भेजा था, कोर सैंपल, तो वहाँ पे जो सॉइल जो कंसल्टेंट थे, उन्होंने एन वैल्यू अज्यूम कर ली थी. मैं वहाँ पे ट्रेनिंग हूँ उस कंसल्टेंट में अभी फिलहाल. तो मुझे ये नहीं समझ में आया कि उन्होंने एन वैल्यू अज्यूम.
नहीं, वो कर नहीं सकते हैं एन वैल्यू अज्यूम. जहाँ तो एसपीटी किया हो, वहाँ पे जहाँ आपके पास प्रॉपर सैंपल आपने लिया हो, वो उन्होंने काम चलाने के लिए एन वैल्यू ले लिया कि परमिशन मिल नहीं रहा है. हो सकता है किसी और ब्रिज का यही एन वैल्यू हो, और उन्होंने अपना काम चलाने के लिए वो एन वैल्यू ले लिया, जो कि गलत है. नहीं करना चाहिए ऐसे.
हाँ
उसकी
जी
कोई गारंटी नहीं है कल को वो स्ट्रक्चर सेफ रहेगा कि नहीं।
हाँ
दिग्विजय, यस
ठीक है।
यू कैन यूज अ बिट ऑफ। आप क्लियर है राहुल, और कोई क्वेश्चन है आपको?
नहीं सर, बस
ठीक
अभी
ठीक,
फिलहाल
ओके,
इतना ही सर।
ठीक है। Digvijay, yes, you can use that, but I don't prefer designing things in the bridges software. I prefer hand calculations more in the starting. That will give you more confidence, and also you can see if you are doing it correctly or not. You can do anything in the softwares like in Midas and Sophistic as well. You can do a lot of things, but I prefer not to use them. For well foundations, it depends how much scouring is there. Like in Ganga, generally we have 10 to 15 meters of scouring. So generally we have to balance out those forces. Then mostly I can say till 30 meters you can say, depth 35 meter as well. I have constructed 135-meter well as well in Bihar Sharif. So 35, I think you can go because of liquefaction. The soil was around 18 meters was liquefiable, so we had to go till 35 meters in that case. Generally, if you ask, then we can say 20 to 30 in between. Lateral load, yes, obviously lateral loads. There are different lateral loads. Mostly, we will cover all the braking, acceleration on the bearings that we have, and also the component of earthquakes. I think that you can talk to Sandeep afterwards.
We'll be letting you know that the class schedules will be starting by next week. Actually, we'll start the registration process from, and we'll start the registration. So we'll let you know timings and all. Actually, our mobile application for Illustrator.com is already live in Play Store. So in just a few days, we'll be setting up this and set the classes. You guys can download this, and from there itself, we'll be conducting all the classes from now.
What type of support bridges have if there is a bearing pads? You can have both simply supported and continuous as well. Every bridge will be based on a bearing. You can make them deck continuity. You can use deck continuity as well. So both of them you can have simply supported and continuous. Bearing will be there in all the bridges, unless and until you are making it integral. Then you don't have bearings. So you can have a deck continuity even when the bearing pad is there. Any other question? Best bridges for bridge engineering. I would say you can go with the Raina. There is a book by Raina. That's a good book, I can say, and in a simple language as well. And also do read all the IRC codes. So a combination of Raina and IRC codes. And then again, for different aspects, there are different books available in the market. So, but stick to Raina, I would say, for most of the things.
So we'll take two more questions. If you have any questions, you can write it here. Then we're gonna finish this live actually.
It's VK Raina in case you are not able to search it. It's VK Raina, Manjunath.
You guys don't have any question, right? Okay, so let me just brief you with the course that we are going to launch in few days. That will be a single part, a particular part of the total bridge engineering, which will be the superstructure part. As sir already explained what superstructure is and what substructure is. So, Abhisht, I'm sharing my screen.
Okay,
Hello.
sure.
I hope you guys can see my screen. So this is the content. This is the brief of the total content. I cannot write everything here, right? So I've just made a brief. You can see the contents. You'll be learning about the basic bridge engineering. First of all, we need to know the basics, right? Then, well, you are going to create or you are going to construct a bridge, then you have to know different aspects while selecting the sites, okay, where you need to go for which kind of bridge. So we'll be knowing about this. Then we have the RCC slab design. Then we have the RCC T-beam design. Sir already explained all these things are, what all these things are in this webinar. We have this PAC T-beam design, Tech slab design. Then we have different types of bearings, what are the kinds of bearings we have and where we should use those things. Then we have selection of spans. Yeah, that is very important in case of bridge, right? So where we should go for up to what is the extent of the span. Okay, so you need to know about this. Then we have the grillage modeling. Okay, sir will explain this. Then we have the design based on limit state method. As sir said, we need to go for designing the bridge with limit state method and different loads as per the Indian Road Congress codes, IRC codes. Because without loading, that bridge design is not, it is not possible to design a bridge, right? What are the loads you need to consider and how they are going to act on your bridge? Okay, so all these things will be covered in this course. This course will be of total 18 hours. We just change the, yeah, you can see this course will be of 18 hours. The whole 12-hour will be covered while explaining the concepts, the manual calculations, different aspects. Then you have to understand the design approach, how to solve those approaches, how to solve those problems while constructing a bridge, and the theoretical explanations. Obviously, you need to know the theory well before going to the project or solving the project, right? Then we'll have 6 hours for project solving and assignments. And while solving the projects and completing the assignments, you guys will be using the StatPro, and sir will be explaining also in StatPro software. Course fee is already written there. You can see here it will be 5,000 for this 18 hours of classes. The classes will be taken through our mobile app, illustrator.com app, which is already live in Play Store. We'll be setting it up in few days, and we'll be starting our classes from next week, most probably. We have created one group also for people who are really interested or willing to join this bridge design course by Abhisht. And if you want, I can share the link of the group in the chat so that you guys can get it. Let's share the link. Give me 1 second. So I have shared the link and also the syllabus about our course. So yeah, this is it. That is what I was going to tell you. This is the course content. So if you guys have any query on our course, on the course content, you guys can write on our WhatsApp group actually. You can join the group and you can ask there your doubts regarding the course. We'll try to answer your solve your queries. So, and I'm really thankful to Abhisht for his time today, for this amazing webinar. And I'm thankful to all of you for joining us today. So I think this is it. I think this is enough for today. We'll be signing off. And you guys can join our WhatsApp groups. It will be better so that we can discuss all the things there. We have 3 WhatsApp groups actually. One is for bridge design, which I have shared here already the link. And other 2 are there for basic and civil engineering discussions. So any of you can put your questions, and our community is there. Anyone can answer this. We'll be trying to answer your questions. Okay. So yeah. So this is it. Abhisht sir, do you want to say anything?
Yeah. Yeah, thank you for this wonderful session. Quite a nice bunch of people who asked good questions, and it was a good, discussion regarding everything.
Yes.
Hope to see most of them in the lecture part as well.
Yes. So yeah. So thank you all of you. I think I'm going to leave this session.
Yeah. Yes.
Fine.
Thank you so much, everyone. Bye.